In the early days of 1939, the German military high command realized they had a fundamental speed glitch in their doctrine. The Blitzkrieg was designed to move at the speed of an engine, with Panzer Is and IIs racing across the plains of Poland and France. But the artillery, the heavy hitters that were supposed to clear the path, were still being pulled by horses or slow-moving half-tracks. This created a lethal synchronization error, where the tanks would outrun their own fire support, leaving them vulnerable to counterattacks while the big guns were stuck in the mud miles behind the front line. The solution was the birth of the self-propelled artillery, or stern artillery, a concept that would change the face of ground warfare by mounting massive howitzers directly onto tank chassis. The first true manifestation of this industrial hack was the Wespe, or Wasp. German engineers took the chassis of the obsolete Panzer II, a tank that was already failing as a frontline fighter, and performed a repurposing glitch. They stripped away the turret, moved the engine forward, and created a high-walled open compartment in the back to house the 10.5-centimeter LEFH-18 howitzer. This wasn't just a modification, it was a total system overhaul. By putting a divisional-level gun on tracks, the Germans created a weapon that could fire a 33-pound high-explosive shell over 6 miles and then scoot to a new location before the enemy could triangulate their position. The Wespe was the mobile sniper of the German battery, providing a level of rapid response fire that the Allies wouldn't be able to match until much later in the war. But the Wespe was only the lightweight patch. As the war shifted to the brutal, frozen expanses of the Eastern Front, the German army encountered a heavy armor glitch in the form of Soviet fortifications and massed infantry waves. They needed more data deletion power. This led to the creation of the Hummel, or Bumblebee. This machine was an industrial fusion, using a hybrid chassis made from both Panzer III and Panzer IV parts. It was designed to carry the massive 15-centimeter SFH-18-1 howitzer, a gun so powerful that its shells weighed nearly 100 pounds. When a Hummel battery opened fire, it wasn't just a bombardment, it was a structural reset. The Hummel allowed the Germans to bring siege-level firepower directly into the heat of a moving battle. However, the ghost in the machine for these vehicles was their lack of protection. Because they were built on existing tank hulls, the weight of the massive guns meant the engineers had to sacrifice armor. These vehicles were paper-thin defenses, often just enough to stop small arms fire or shrapnel. They were glass cannons in the truest sense, capable of deleting anything in their sights from miles away. But if a single Soviet 34 managed to get close, the Wespe or Hummel was essentially a mobile coffin. This forced a radical change in tactical source code. The artillery crews had to become masters of terrain exploitation, using hills, forests, and the curve of the earth as their primary shield. The research into these machines reveals a desperate logistics glitch that haunted the German SPA program from day one. Because they were using legacy hardware like the Panzer II and III chassis, the spare parts supply was a nightmare. A battery of Wespes often had to be cannibalized just to keep 1 or 2 vehicles moving. Yet, despite the mechanical failures and the lack of armor, the mobile firepower glitch was so effective that it became the blueprint for every modern army on the planet. The Wespe and Hummel weren't just vehicles, they were the first step toward a world where the big guns never stopped moving, turning the battlefield into a high-speed game of delete or be deleted. By 1943, during the massive lead avalanche of the Battle of Kursk, these self-propelled batteries were the only thing keeping the German lines from being completely overrun by the sheer volume of Soviet steel. They were the final firewall of the Blitzkrieg, proving that in the chaos of war, the most powerful weapon isn't the one with the thickest armor, but the one that can move, strike, and vanish like a ghost in the smoke.
The German army's mobile firepower glitch reached its most terrifying and illogical peak in 1944 with the birth of a machine that felt less like a vehicle and more like a building deletion tool. This was the Sturmtiger. By this stage of the war, the German High Command was facing a systemic urban glitch. In cities like Stalingrad and Warsaw, traditional tanks were being picked apart by infantry hidden in reinforced concrete buildings. Standard tank shells were simply too small to reset these structures. The Germans didn't need a better tank, they needed a structural delete button. They decided to take the battle-hardened chassis of the Tiger I, the most feared heavy tank of the era, and perform a heavy weapon hack that would defy the laws of conventional ballistics. The hardware glitch at the center of the Sturmtiger was its armament. German engineers realized that no standard gunpowder cannon could fit inside a tank and still be powerful enough to level a fortress. So they looked to the Navy. They took a 380mm rocket-boosted mortar, originally designed by Rheinmetall for coastal defense against battleships. This weapon didn't fire shells, it fired massive 800-pound depth charges filled with nearly 300 pounds of high explosives. This was a physics exploit. Because the projectile was a rocket, it didn't require a long, heavy barrel to build up pressure. Instead, the short snout barrel was vented with a ring of holes to allow the rocket's exhaust gases to escape, preventing the massive pressure from imploding the tank itself. When a Sturmtiger fired, it looked like a volcanic eruption, launching a projectile that could travel over 6,000 yards and penetrate 2.5 meters of reinforced concrete. However, this power glitch came with a massive reloading latency. The rockets were so heavy that the tank could only carry 14 of them. To get a new round into the breech, the crew had to use an external crane mounted on the back of the superstructure. It was a slow, agonizing process that left the vehicle completely vulnerable. In the tactical source code of urban warfare, this made the Sturmtiger a single-click weapon. You moved into position, deleted a city block, and then spent the next 20 minutes trying not to be destroyed, while the crew manually winched another 800-pound system reset into the tube. The armor of the Sturmtiger was a defensive overclock. To protect the crew from the chaos of street fighting, the front plate was sloped and thickened to 150 millimeters. It was practically unkillable from the front by any Allied anti-tank gun in existence. It was a mobile bunker, a 65-ton wall of steel that could ignore incoming fire while it lined up its one-shot kill. But this weight created a mechanical crash. The Tiger I chassis was already pushed to its limit, and the added weight of the Sturmtiger's armored box and its massive rockets meant the transmission and engine were constantly failing. It was a disposable god, capable of incredible destruction, but prone to system failure after moving only a few miles. The most famous execution of the Sturmtiger occurred during the Warsaw Uprising. Here, the urban deletion glitch was used with horrific efficiency. A single shot from a Sturmtiger could collapse an entire multi-story apartment complex, killing everyone inside instantly and turning the rubble into an impassable barrier for the resistance. There is even a recorded instance of a Sturmtiger firing at a group of Allied tanks in a village, and the blast wave alone being so powerful that it disabled 3 Shermans at once without a direct hit. It was the ultimate area of effect weapon. In the end, only 18 of these math monsters were ever built. They were too heavy, too slow, and arrived too late to change the industrial avalanche falling on Germany.
The Sturmtiger remains a bizarre anomaly in the code, a reminder of a time when the pressure of total war forced engineers to build the impossible. It wasn't a tank, it was a 65-ton eraser designed to fix a problem that the German army could no longer win. It proved that while you can build a gun big enough to delete a building, you can't build a machine big enough to delete a losing war.
While the Sturmtiger was a city killer, the German military had one final massive scale glitch in their arsenal, the Karl-Gerät. This wasn't just a vehicle, it was a superweapon exploit designed to solve the problem of the most heavily fortified walls in Europe, specifically the Maginot Line. It was a self-propelled siege mortar so gargantuan that it made the Tiger tank look like a toy. It was the largest self-propelled gun ever to fire a shot in combat, a literal, industrial monster that pushed the boundaries of what physics would allow. The hardware specs of the Karl-Gerät were terrifying. It stood over 15 feet tall and weighed 124 tons, more than 2 modern main battle tanks combined. It carried a short, stubby 600-millimeter barrel that fired a bunker-busting payload weighing over 4,000 pounds. When this 2-ton shell hit its target, it didn't just explode, it created a localized earthquake, capable of penetrating 8 feet of concrete or 14 inches of steel plate. This was the ultimate hard drive wipe for enemy fortresses. However, the mobility glitch was its fatal flaw. Although it had tracks and a 580-horsepower engine, it moved at a pathetic crawl of just 6 miles per hour. It was so heavy that it would crack the pavement of normal roads and sink into soft soil. To actually move it long distances, the Germans had to perform a system deconstruction, breaking the massive gun down and transport it on specially designed railway bogies. Even its ammunition required a support patch, a modified Panzer IV tank acting as a crane carrier just to lift the shells into the breach. The Karl-Gerät's most famous deployment was the siege of Sevastopol in 1942. The Soviet fortresses were built deep into the rock, designed to survive anything the German Luftwaffe could drop. But the Karl-Gerät executed a stability hack. By firing its massive 600-millimeter rounds, it cracked the deep concrete glitch-proof bunkers, forcing the Soviet defenders into submission. It was a victory of pure, overwhelming mass over engineering. Ultimately, the Karl-Gerät was a system failure. Only 7 were built, and they were so slow and resource-heavy that they were more of a logistical nightmare than a tactical advantage. By 1945, as the Allied industrial avalanche closed in, these behemoths were either captured or blown up by their own crews. The Karl-Gerät proved that in the evolution of war, the size glitch has a limit. You can build a gun that deletes a fortress, but if the machine is too big to move, it eventually becomes its own graveyard.